Hello everyone, today I'm going to introduce Introduction to CMOS VLSI Design Project, which is IC design of 64-bit digital correlator. These are the software programs that are used throughout the project. Our project composed of three different parts. In the first part, we develop and test the VHDL code of 64-bit correlator. In the second part, we generate the chip, and in the third part, we make our design testable. In the first part, at the beginning, we are given some requirements. As you can see, we have 5 different input pins: clock, in, program, reset, and progin. And we have 3 different output pins: sync, sync no, and data pole. The working logic of our correlator is following. Our correlator takes serial input data, compares bit by bit with 2 different 64-bit patterns, and if the error of the pattern is less than the error tolerance, which is given as input, it signals sync and signals the match pattern as sync no, and whether the data is inverted or not is given as a data pole. Here you can see the result. At first, sync 1, sync no is 0, and data pole is 1, which means data is matched, and it's matched with the first pattern, and data is not inverted. In the second part, sync no becomes 1 since it's matched with the second pattern, and data pole is again 1. In the second part, sync no is 1, but now data pole becomes 0 since data is inverted. In the last part, sync is 0 since error is more than error tolerance. It means there is no match. In the second part, which is chip generation, we have used 2 different programs, GANUS and INOVUS. In GANUS, we generate gate level model of the design in part 1. Here you can see the synthesis of gate level design. And in INOVUS, we generate layout of gate level Verilog file. Before passing to INOVUS, I made lots of trials in order to minimize the energy delay product. Here you can see the minimum energy delay product, which is obtained in 1.8 volts in 105 nanoseconds. After completing this part, the gate level Verilog file was obtained in order to use it in INOVUS. In INOVUS, the most crucial part is clock tree optimization. The purpose of clock tree optimization is the decreasing the clock skew. And in the last part, we have the finalized chip. Here you can see the power lines and all of the connections. And the generated GDS file was imported to Cadence Virtuoso in order to see the layout. Here you can see the layout of the GDS file. The most important thing after completing a design of a chip is testing a chip. So in part 3, we make our design testable, and for that purpose we use a scan technique, which is adding a shift register in order to make our design testable. We also add new pins, and in Modus we generate test patterns for testing the chip after fabrication. And like in part 2, we perform placement and routing operations, but with addition of scan flip-flops. In Tempos, I get timing info, which are setup slack time and hold slack time, can be seen here. In Voltus, I got total power information and total area information. At last, here you can see the finalized chip design and final layout. Thank you for listening.